Hi guys, this is Engineer Jack. So before tayo mag-analyze of doubly reinforced concrete beams, so balikan ko muna guys yung analysis of singly reinforced concrete beams, and this time yung condition if our steel does not yield. Kasi sa mga unang example problems natin sa channel ko, yung assumption natin doon is lahat naka-yield. Pero this time, paano nga ba if our steel does not yield? So, if our epsilon S or net tensile strain is less than the yield strain or epsilon Y, or yung epsilon S natin that's less than 0.002. So, yung 0.002, galing yan for Fy na 400 megapascal. Kasi nga, pag nag-divide tayo ng 200,000 megapascal, makukuha natin is value for strain. Kasi nga, yung stress natin that is equal to epsilon strain times the modulus of elasticity. So, equal lang naman yan. Or, pag nag-less than nga yung epsilon S natin sa 0.002, that is compression-controlled section. Ngayon, kung babalikan natin guys yung formula for our epsilon, that is equal to 0.003 times d minus c all over c. So, nakuha lang natin yan sa strain diagram natin, ay naggamit lang tayo ng ratio and proportion, so simple mathematics. Tapos, ginamit natin guys yung similar triangles. Pero guys, if we have two or more layers, ito naman yung formula natin for net tensile strain. So that is 0.003, closing parenthesis, dt naman gagamitin natin minus c all over c. So yung dt natin, ito yung location from the topmost area hanggang dun sa centroid ng our first layer. So yung pinakamalapit sa tension phase natin, doon natin kukunin yung value of for dt natin. Na yung epsilon t natin or epsilon s, yan yung kinukonsider natin para malaman natin kung anong gagamitin natin na strength reduction factor phi. So, kung balikan ulit natin guys yung formula for our nominal moment strength, that is Mn, and equal lang naman yan sa ASFy times D minus A half. So, yung ASFy, that is T. So, pwede natin gamitin yung bigger C. So, that is 0.85 Fc prime AB. So, ginagamit lang natin ito if our steel yields. So, ibig sabihin, if our actual stress in our steel is greater than the yield strength or Fy. So, yung actual stress nga natin, or Fs, that is epsilon S, or net tensile strain, times the modulus of elasticity for steel, so ES. Na meron tayong value for epsilon S na ito nga, na 0.003 D minus C all over C times 200,000 megapascal. So, pag simplify natin yan, so 0.003 times 200,000, that is 600. So, yung formula now natin for actual stress for steel, so itong value na 600 times D minus C all over C, and syempre yung unit niya naka-megapascal. So, for in case na tension controlled, yung Fs natin should be 1,000 megapascal, or that is 0.005 na net tensile strain. So, kung mag-multiply lang tayo ng 200,000 megapascal, that is 1,000 megapascal. So, kung gumagamit kayo guys ng Fs, pa na greater than 1,000 megapascal, automatic that is tension-controlled section. So, for this time nga, yung i-consider natin, if Fs is less than Fy, yung gagamitin natin na formula for our Mn, that is ASFS na, times D minus A halves. So, last time, if our steel yields, especially pag greater than sa 1,000 megapascal, automatic that is tension controlled, and automatic that is greater than Fy. Kaya ang ginagamit natin last time is Fy. So this time, pag nag-less than, yung gagamitin natin na formula is Fs na. Na yung formula nga natin for Fs, that is 600 times D minus C all over C, and yung unit niya naka-megapascal. So, yung nakuha natin ng Fs na kinumpare natin sa Fy, hindi yun yung value na isa-substitute natin dito sa formula for Mn. So, mag-recompute tayo for value of C and yung value for A. So, babalikan pa din natin yung formula na T equals to C, and for tension force natin, yung gamitin natin is ASFS na, and sa kabila for C, same pa din na 0.85 Fc prime times A times B. So, substitute the value for Fs, itong value nga na 600 times D minus C, all over C. And for value of A, yung gagamitin natin is beta 1C. Tapos, after equate natin yan, we will solve the value for C and the value for A. So, para makuha natin yung value for A, that is only beta 1C nga. And after that, i-recompute natin yung new value for Fs, itong formula. Tapos, yung value natin for new Fs, yun yung gagamitin natin for this formula na Mn, na ASFS. So, yung finally, if our steel does not yield, yung gagamitin natin na design strength, that is Phi ASFS times D minus A halves. So ngayon, pag-usapan naman natin yung analysis of doubly reinforced concrete beams. So paano ba natin nasasabi if our beam is doubly? Para malaman natin guys, if we have given a doubly reinforced beam, i-compare lang natin yung value for raw, and kung greater yan sa raw max natin, definitely that is doubly reinforced beam. And some reference din, gumagamit sila ng AS lang, so equal lang naman yan kasi pag multiply tayo ng BD, that is AS or AS max. Yung raw natin na ginagamit, that is for rectangular only. And for AS, ginagamit yan for any shape. Pero usually, yung ginagamit natin is raw and raw max. And some reference naman guys, kung gumamit tayo ng design strength tapos yung ginamit natin na AS max, tapos less than pa din sa factored moment na MU, automatic kailangan natin ng additional reinforcement for our tension steel and kailangan natin ng reinforcement sa compression. Kaya tayo nagkakaroon ng doubly reinforced kasi nga, kahit gamitin natin yung pinaka-maximum area na AS max, kulang pa din yung strength niya tapos less than pa din sa MU. Kasi diba, yung design strength natin for beam or VMN, that should be greater than or equal to MU. Pero kung yung case nga is less than, kailangan natin additional reinforcement. So yung AS max natin, that is raw max BD lang. So nag-multiply lang tayo ng width and effective depth to solve the AS max. And ito yung ginagamit natin dito to solve the design strength of our singly. So yung raw max natin, that is 0.75 raw balance. And that is from old NCP. To be specific, that is NCP 2001. Pero guys, for foreign references, yung ginagamit nila for raw max, that is 0.003 plus yield strain or epsilon y all over 0.003 plus 0.004 times raw balance. So yung 0.003, ito yung maximum strain nga natin for our concrete. And yung 0.004 naman, galing naman yan sa net tensile strain na limit natin na dapat hindi magbababa sa 0.004 para ma-design natin yung beam. So that is in transition region nga kasi less than 0.005. So pag i-simplify natin yan, so yung raw max natin, that is 0.003 plus epsilon y all over 0.007 times raw balance. So ito yung ginagamit ng mga foreign references, pero actually guys, ginagamit din to sa NCP in a different way. So papaliwanag ko yan sa mga example problem dito sa doubly reinforced. Ngayon, pag nagamit tayo ng Fy ng 400 megapascal, or that is epsilon y ng 0.002 kasi mag-divide tayo ng 200,000 megapascal, that is 0.002. So pag sinubstitute natin yung value for epsilon y dito sa equation, magkakaroon tayo ng 0.003 plus 0.002 all over 0.007 times raw balance. And that is also equal to 0.714 raw balance. Halos pare dito sa old NCP na 0.75 pero meron pa rin difference. And itong formula, hindi yan guys yung isa sa ulo nyo kasi ginagamit lang yan for Fy na 400 megapascal. Pero kung iba yung value natin for yield stress or yield strength na Fy, yung isa sa ulo natin na formula is this value. So ito na 0.003 plus epsilon y all over 0.007 times raw balance. Ngayon, yung ginagawa natin sa design, if our factored moment na MU, so nasolve yan galing sa factored loads natin, and if it's greater than sa design strength, so kahit gumamit tayo ng maximum steel reinforcement na AX max, so kung less than pa din yan, so yung solution natin para madagdagan yung design strength natin na dapat mag-equal sa MU or mag-greater than sa MU, yung solution natin, pwede natin palakihin yung section, so pwede natin palakihin yung beam width na B and the effective depth or the total depth of the section. Or, we will use double reinforced beam or DRB. So, ang gagawin natin, pwedeng same pa din na section, so same width and effective depth, pero magdadagdag tayo ng additional reinforcement sa tension reinforcement or sa bottom bars, and magdadagdag tayo ng compression reinforcement or yung top bars natin. So, this time, if we have 2 or more layers, yung effective depth natin sa centroid of our tension steel reinforcement hanggang dun sa topmost layer. And yung gagamitin natin na DT, na ginagamit natin for net tensile strain, yung kukunin natin from the centroid of the first layer or yung pinakamalapit sa tension phase hanggang dun sa topmost area. And this time, meron tayong kinatawag na D prime. And galing yan sa centroid of our top bars or yung compression steel reinforcement hanggang sa topmost area. So actually, sa design of our beams talaga, kung nangyari talaga is MU is greater than the design strength, kahit gumamit tayo ng AS max, yung solution natin is DRB, hindi yung papalaki natin yung section. So if the external refractored moment nga or yung MU is greater than the design moment strength, more compressive and tensile reinforcement must be added. Kaya nga nagdagdag tayo ng reinforcement sa baba and nagdagdag tayo ng bar sa taas. So yung compression reinforcement is used when the section is limited to specific dimensions due to architectural reasons such as a need for limited headroom in multi-story buildings. And another advantage of additional compression steel reinforcement, yung long time deflection natin is reduced. So, kung mapansin nyo, meron tayong additional designations guys. So, yung tensile steel natin, yung ginagamit natin na variable is AS. And for compression steel natin, yung ginagamit natin is AS prime. If our rho is less than rho max, so we should analyze the beam as SRB or singly reinforced beam. Pero if our rho is greater than rho max, we should analyze the beam as doubly reinforced beam na. Kasi magkaiba guys yung pag ina-analyze yung singly and doubly. So yung singly, ika-consider natin is yung AS. Pero for doubly, ika-consider natin yung AS prime. And yung rho natin na kukuha yan, that is AS over BD. And for rho max, yung gagamitin natin now is itong value na 0.003 plus yield strain na epsilon y all over 0.007 times rho balance. So, hindi natin guys gagamitin yung 0.75 rho balance kasi galing yun sa old NCP nga or sa NCP 2001. So, ito lang yung common na nakikita natin for our double reinforced beam. So, parang singly lang siya. May additional lang tayo ng reinforcement sa taas or AS prime. So, this time, meron tayong additional na CS. Ito yung designation natin na C for our compression reinforcement. And for our concrete, yung gagamitin natin symbol is CC. So, yan yung mga bago sa double reinforced na variables or designations. So, meron tayong CS, CC, AS prime, D prime. So, yun lang naman yung mga bago. So, yung AS prime nga natin, that is compression steel. D prime, that is the steel cover. CC is 0.85 FC prime AB pa din. And for CS, yung additional natin reinforcement, that is AS prime times FS prime or FY. So, ipapaliwanag ko mamaya bakit meron tayong dalawang stress. So, pwede kasing FY or pwedeng FS prime. So, itong figure natin for doubly reinforced, pag inanalyze natin yung beam, equal lang yan using singly reinforced and yung additional reinforcement natin for tension and compression steel. So, for example, meron tayong 4 na tension steel. So, pwede natin i-divide sa dalawa yan. So, if we has AS1, ito yung figure niya, tapos this is for singly lang. And yung dinagdag natin na reinforcement, that is AS2, and sa taas, that is AS prime. So, ito yung mga additional reinforcement natin. So, pag kinumpute natin yung MN yan for singly, same pa din na pag nag-moment tayo sa tension force, yung force na CC times moment arm na D minus A halves, so that is 0.85 FC prime AB pa din, times D minus A halves. And sa kabila, yung dinagdag natin na reinforcement, yung MN dyan is, let's say that is MN2, and that's also equal to, pag nag-moment tayo sa tension reinforcement pa din, so yung CS times yung moment arm niya, so yung distance niya from the tension steel, that is D minus D prime. Kasi nga, yung location of our tension steel from the topmost, that is effective depth or D, and meron yung location of our compression steel from the topmost, that is D prime. So yung difference niyan, that is D minus D prime. Kaya yung moment arm niya is D minus D prime. So yung MN1 nga natin, this is the moment due to the tension reinforcement that balances the compression concrete. And yung MN2 natin, this is the moment due to compression reinforcement and equal amount of additional tension reinforcements. So yung total nominal moment strength natin is the sum of MN1 and MN2. So using these values guys, so meron tayong T1 and T2, CS and CC. Pag nag-summation of force horizontal tayo, or pwede natin equate lahat ng forces na to the right sa forces to the left, yung direction. So basically, meron tayong equation na T equals to CC plus CS. So yung T natin, that is T1 plus T2 lang. So same lang naman yan. This time, if we assume that tension and compression is still yields, or yung gagamitin natin for equation, for our stress of our tension steel and for our stress for our CS or compression steel, gagamitin natin is Fy. So yung equation natin now is meron tayong T1 na AS1FY and AS2FY for T2. So sum niyan, pwede natin i-factor out yung FY. Kaya AS1 plus AS2 times FY. And sa kabila, meron tayong CC na 0.85 FC prime AB. And yung CS natin, that is AS prime FY. So nag-assume na tayo this time na yung tension and compression steel yields nga. Kaya yung ginamit natin na multiplier for our area for tension steel and compression steel is Fy. Kasi inequate natin yung Fs and Fs prime sa Fy natin. Simplify natin itong equation. So yung AS1 and AS2, pwede din sabihin natin that is AS. So AS Fy is equal to 0.85 FC prime AB plus AS prime Fy. So pwede tayo makagawa ng equation for A that is equal to AS minus AS prime times Fy all over 0.85 FC prime B. So galing lang yan dito sa equation. So yung C natin, that is A over beta 1. Kailangan natin yan to check the value for Fs and Fs prime. So we should check the Fs and Fs prime. So yung Fs, this is the actual stress of our tension steel. And yung Fs prime, this is the actual stress of compression steel. So ngayon guys, kung babalikan natin yung strain diagram natin, ito lang yun. So meron tayong epsilon S and this time may additional tayo na epsilon S prime. So yan yung location D prime from the topmost area. So kung mag-relation proportion tayo for our net tensile strain, so dito sa tension steel, kung gagamitin natin is epsilon S. So galing lang sa similar triangles and that is 0.003 times D minus C all over C. Pero guys, kung kukunin natin yung epsilon S prime, mag-relation proportion na tayo. So using this smaller triangle and the bigger triangle, by relation proportion, let's say itong base all over height, epsilon S prime, all over yung height niya na smaller triangle, that is C minus D prime, is equal to yung bigger triangle na meron siyang base na 0.003 and meron siyang height din na C. So pag simplify natin yan, meron tayong formula now for our epsilon S prime, that is 0.003 times C minus D prime all over C. Pero guys, pwede natin guys i-multiply yan na values for our epsilon. Pag multiply tayo ng modulus of elasticity, so we can have the value for Fs that is 600 times D minus C all over C. And for Fs prime naman, meron tayong value na 600 times C minus D prime naman. So itong formulas kailangan natin tandaan para malaman natin if our steel yields or not. Ngayon, kung chinek natin guys yung value for Fs and Fs prime, using na nakuha natin na value for A and C, for Fs na greater than sa Fy, ibig sabihin the tension still yields. And if Fs prime naman is greater than Fy, ibig sabihin naman the compression still naman nag-yield. So ibig sabihin, yung value natin for A and C is correct. Ngayon, pag tama nga yung value for A natin and C, automatic, diretso tayo guys sa formula na Mn. That is equal to Mn1 plus Mn2. And meron tayong value for Mn1 na 0.85 Fc prime, AB times D minus A halves, and AS prime naman, Fy times D minus A halves. Oh my God! So ginagamit natin itong formula only if our tension steel and compression steel nag-yield. So yung Fs nga and Fs prime na greater than. So kailangan natin guys always i-check yan para automatic ito yung gagamitin natin na formula. Another situation naman, if our Fs greater than pa din sa Fy or the tension still yields, pero this time yung Fs prime natin is less than Fy naman. Or yung compression still natin does not yield. So ngayon, if that happens, ibig sabihin, mag-resolve tayo for value for A and value for C. So itong nakuha natin na formula for this A and for this C, mali yan. So mag-resolve tayo using this equation. So yung gamitin natin, for AS times Fy pa din, kasi nag-yield yung tension still natin. Pero for AS prime natin, this time, yung gamitin natin is Fs prime. Kanina, naggumamit tayo ng Fy kasi nag-assume tayo ng Fs prime is equal to Fy. Galing lang yan sa C equals to T natin or T is equal to Cc plus Cs. So, gagamitin lang natin itong formula only if our compression steel does not yield. So, substitute the value for Fs prime, that is 600 times C minus D prime all over C. And for our value for A, that is beta 1 times C. So, using this equation, i-solve natin yung value for C. And after natin ma-solve yung value for C, saka natin magagamit yung new formula for our Mn. So this time, yung nagbago is yung Fs prime. So yung Fs prime natin this time, para makuha natin yan, just use this formula na 600 times C minus D prime all over C. So yung C natin dito, ito yung bago na value for C natin na ginamit natin using this equation. So finally, ito yung kailangan natin na isaulo if our steel does not yield. So to summarize, yung step number 1 natin for analyzing doubly reinforced concrete beam, i-check muna natin yung given na rho if it's greater than rho max. So if that happens, ibig sabihin, analyze the problem as doubly reinforced beams. And if not, ibig sabihin, automatic i-analyze natin yung problem as singly reinforced beam. So kahit may given na compression steel, just neglect that if our rho is less than rho max. Na yung rho max natin na isa sa ulo is itong formula nga na 0.003 plus epsilon y all over 0.007 times rho balance. Tapos number 2, after natin ma-check yan, we will now equate the T equals to C. Or yung T natin, or T1 plus T2, and sa kabila na C, meron tayong dalawa na CC and CS. So after natin ma-equate, we will assume that tension and compression still yields. So, ibig sabihin, gagamitin natin stress for our T is Fy and for our CES is Fy din. So, in-equate lang natin yung Fs prime sa Fy. So, after equate natin yan, we will solve the value for A and C. Number 3, we will check naman the Fs and Fy using formulas na for Fs, 600 times D minus C all over C. And for Fs prime naman, itong formula. And for Fs nga, if it's greater than Fy, the tension still yields. And yung for Fs prime naman, if it's greater than Fy naman, yung compression still natin yields. So, ibig sabihin, yung value natin na nakuha for A and C, that is correct. Pero guys, if Fs is greater than Fy, the tension still yields. But yung Fs prime natin is less than Fy, that is compression still does not yield. So, pag nangyari yan, we will resolve the value for A and C. Using this equation na A as Fy is equal to 0.85 Fc prime beta 1C times B plus AS prime times yung value natin for Fs prime 600 times C minus D prime all over C, closing parentheses. So, yung gagamitin natin na equation to solve the value for new A and new value for C. So next step number 5, we will calculate now the design strength or VMN. Na yung formula natin now for Mn, that is CC times moment arm niya or 0.85 Fc prime AB times D minus A halves plus AS prime Fs prime or Fy times D minus D prime. So yung Fy gagamitin natin if our tension steel and compression steel nag-yield. Pero, pag yung tension steel natin nag-yield, tapos yung compression, hindi, yung gagamitin natin is Fs prime. Pero guys, baka may magtanong sa inyo, bakit walang sitwasyon na yung tension does not yield din? Or pareho hindi nag-yield yung Fs natin and Fs prime. So, hindi guys pwede mangyari yon kasi kaya nga nagdagdag tayo ng reinforcement kasi kulang. So, kung hindi nag-yield din yung tension, ibig sabihin, hindi natin kailangan ng compression steel or sobra yung ginamit natin na bakal. Kaya nga hindi pwede yung mangyari kasi nga nagkakaroon tayo ng double reinforced beams kasi kulang yung reinforcement natin. Kaya dalawa lang yung situation natin. So, meron tayong tension steel and compression steel pareho nag-yield. And another situation, yung tension steel yields natin and yung compression steel does not yield. So that's it guys. Thank you very much and have a good day.